The mate reference tool allows you to add a reference entity to a part or multiple parts so they can be quickly mated together in an assembly. If you create a mate reference between two parts and you're adding a specific part to an assembly, it'll automatically add those mates. So we're going to go ahead and create an assembly from this shaft MR. And you can see the other three documents that I opened up were the collar MR, collar MRD, and shaft MR. So I'll go ahead and choose the shaft MR, select the Feature Manager design tree, open it up, and click on the origin. And that's how I like to add in parts, or the first part in an assembly. I like to line up the planes in the part with the planes in the assembly. Now that I have that, I'm going to come into the collar MRD, and then we'll come into the reference geometry pull down and choose mate reference. Now this brings in the mate reference property manager, and you can see that the highlighted box is our first selection, a primary reference entity. We can choose a vertex, edge, or a face. And we can choose out 3 different references so that we can add 3 mates to fully define a part. You'll also see a reference name, and we'll use this later when we're matching up 2 parts so that they have the exact same reference entities. In this case, we're going to go ahead and start with just a circular edge, and we'll leave this as default. You'll notice in these pull downs you can choose several options for the mate type, and you can also leave it as default if you think that SOLIDWORKS is going to select the correct mate type. For circular edges, your only option is default because it's going to add both a coincident as well as a concentric mate. So I'll go ahead and exit out of that, and now we have a mate references folder within the Feature Manager design tree, and this will store any mate references we create. I'll go ahead and come back in the assembly, and I'll go ahead and insert in that collar MR. Now you can see if I hover over the circular edges in this part, it's going to add those 2 mates. If I look in the mates folder now, I have a concentric and a coincident. So if you have a part within an assembly, or a part that you're going to add to an assembly, that you know you need the coincident and concentric mate for, quickly adding a mate reference to one of the circular edges is one of the best ways to add that in. Now I'll go ahead and delete out these 2 parts. And now we're going to create a mate reference in both the shaft as well as the collar. And we're going to line those 2 up. So I'll go ahead and edit the definition of the default. And I'm going to go ahead and rename this. I'll just call it dProfile. And for our primary reference entity, I'll go ahead and select out this circular face, or rather this face. It'll produce the same result, but you can choose either one. For the secondary reference, I'll choose this face, and typically we might have a gap between this face and the one in the shaft, so you can make these parallel instead of coincident if we want. I'll go ahead and set the default as concentric as well, since there's no other mate type that we'd want selected. And I'll go ahead and select the front face. Now, when working with mate references, these tend to work the best when the planes and faces are lined up in both of the parts. So you can see how the right plane is oriented in this part. We'll generally want the same in our shaft, if possible. So you can see the right plane passes through that profile in the same manner. So we'll select out this face for that concentric mate, the top face for the coincidence or parallel relation, and the front face for another coincident relation, which will once again leave as default. So once I rename this, when we add that collar into the assembly, it's going to see that these names match up and automatically try to mate the two together. So I'll make this concentric, choose that face, say parallel, and choose the front face and say OK. And those were selected in the same order, so those should work out correctly. If you put this face, for example, in the second reference entity, it won't be able to figure out how to mate this properly, so it will go ahead and not add in that D profile reference. So you want to keep in mind what the order of your selections are. Once again, insert components, collar MR, and now that automatically lines up when it's added in. But I can see that this isn't selected correctly, that we want this face lining up with this face. So there's a few things we can do to change this. I can come in and edit the definition. And one thing you can do is change how this is aligned. Let's try anti-aligned. And delete out that extra component. And try this again. You can see we get the same result when hovering over. So we'll go ahead and try to change this again. Maybe say closest. Come back into the assembly. Insert the component. And we see nothing changes there. So we'll go ahead and try to change this face and see if it works with that inside face. And come back in the assembly and once again insert in that collar. So now this inserts in correctly. So you can see that when you're working with the mate reference tool, you'll want to use it for parts that you're going to be adding in frequently, and you'll want to mess around with that until you get it set up correctly. Once you have this set up correctly, it's going to add in the exact same manner every time. What does work a little bit better with mate references is selecting out edges instead of faces. And we're going to do that with the collar MR, which has this hex profile cut out into it. Now you may be wondering, since the two collars are very similar, if I can create two different configurations and then just use separate mate references. Mate references don't work well with different configurations. You're not able to choose how different entities are suppressed and unsuppressed, so those won't work with different configurations. So for this, we'll create a mate reference once again. We'll align it to the right plane. And I'm going to select out this edge and the side edge. And those two should be enough to fully define the part within the assembly. Then I'll go into the shaft MR, take a look at that right plane. So we'll want to select the top edge and this left edge. And choose those two out. And I'm going to call this hex. And we'll change the name in here from default to hex. Otherwise it wouldn't find that reference. So now if I add this in, this should work correctly. And you'll see if I hover over that face, it adds it in right away. So it is easier to work with edges when working with the mate reference. It tends to find those a little bit better. I did experiment with choosing out the inside faces of the hex as well as choosing the outside face for a coincidence, and couldn't get the two to line up. So sometimes you'll have to keep that in mind and make those changes in order to get the mate reference to work.